Open your textbooks to page 126 in our Algebra 1 book, and we're going to start cost, income, and value problems. Just to be very clear, the cost of something, this is a definition for you, is equivalent to how many you buy multiplied by the cost per. Okay? So the cost per item. If you buy 2 apples, and the apples are 50 cents each, 2 times 50 gives you how much that total cost was, right? Income. Pretty soon you guys are all going to start working. Get you a little cash. Income is the hours you worked multiplied by the dollars per hour. Okay? Back when I was 15, I worked for $3.35 an hour. That was minimum wage. So $3.35 times my hours would give me the income. And finally, value. Value, perhaps you have a collection of something. The value of the item or of your collection is defined by the count of the item. So count of what you're buying, count of hours, count of the item, multiplied by the dollars per item. These are all very similar, aren't they? If you just think of it as how many times the money, you're going to pretty much get what you're looking for. How many hours times what you earn. How many stamps, if you have a stamp collection, times the count of stamps. All right? So this is where we're going to get started today. We're going to go over about 3 examples today, and then I'm going to let you guys work on it, and we'll hit it again on Tuesday. Well, let's get started with our senior class play. Now this is their example, and we are on page 126. Senior class play. How fun. Tickets for the senior class play are $6 for adults, $3 for students. A total of 846 tickets worth, or totaling, $3,846 were sold. How many student tickets were sold? All right. In lesson 3.6, they taught us how to chart, and I highly recommend you continue charting. It helps me, and I know it helps you if you do it. Student versus adult. And then using the same setup, we're going to do the count, the cost per item, and in this case it's tickets, right? And finally, we have a total cost, or total amount. Notice that we're going to multiply the number of tickets by the price per ticket to achieve that cost. Some things are given to us already. They told us that our student tickets are $3 and our adult tickets are $6, right? They also told us the sum of the tickets sold. Okay? Okay? If I know that these two is this amount, then I can call one of those items X and the other one 846 minus X. Okay? One of those is X, the other one is 846 minus X. Just a sidebar for you really quick. Let's say the student, and this is my little sidebar, plus the adult count of tickets totaled 5. Okay, and if I call this one X and I call this one 5 minus X, and I use a number, let's just say I say the number of student tickets is 3, then 5 minus 3 is 2. Does that give me the 5 that I've already asserted is the amount? That's why this works. Okay? If you know the total, then by calling one of them X, and then calling the other one the total minus X, you have a true comparison, okay? Sidebar done. All right, so the total cost is, or the total money involved, $3 per kid ticket and $6 per adult ticket. And remember, I've already explained why these two pieces of information are valuable and why it works. Okay? So the dollars, the total dollars, is students plus adult. Students plus adult, and what is that total dollar amount that they said this thing brought in? $38.46, right? Which means that using that information, you can create an equation. So I've charted. Now I'm going to create an equation. 3x added to 6, 846 minus x equals 3,846. And I'm going to be able to solve for x. That would give me the student tickets. Whatever I get there, if I subtract it from the total, I'll get the number of adult tickets. Who's got a calculator? 6 times 846. He says it's 5076. Very good. 6 times negative x is negative 6x. Bring down your 3x. All of that is equal to 3846. We're going to move some stuff around. We're going to combine our x's for a total of negative 3x. And we're going to get this out of here by subtracting it. Okay, so I've combined my x's and I've moved my numbers. 3846 minus 5076, Noah? Negative 1230. Okay, divide by your coefficient, and the count of x equals 410. Okay, he says it's 410. Okay, so let's now, after we've charted, after we've solved, let's interpret our data. Let's interpret our data. Student is 410. 846 minus 410 is adult. So what's adult? Adult is how many? 436. Now, the question, how many student tickets were sold? All they really cared about was this. Okay, that's all they really cared about. Moving on to the top of page 127. Oh my. Okay, page 127. Marley makes $5 an hour working after school and $6 an hour working on Saturdays. So what we're comparing here is her weekday labors compared to her Saturday labors. Okay? Okay? They have it written the other way, but that's just how I wrote it. Marley makes $5 an hour working after school, so that's during the week, and $6 an hour working Saturdays. Last week she earned $64.50 by working a total of 12 hours. How many hours did she work on Saturday? Okay, we're going to fill in our chart. We're going to create an equation. We're going to solve the equation. Okay, and we're going to use that solution to answer the question. So here we go. First thing that we've got is the count of hours. That multiplied by her dollars per hour. right? Her wages. That will give us her total income. That was one of the 3 scenarios I shared with you already. So, some things I know. I already know, well, they want me to fill this in, so they've given me this. That's the only thing they've given me, right? How much per hour does she earn? Oh no, they want that in the weekdays, or the Saturday spot, because I wrote it backwards. Okay, how much does she earn per hour during the week? $5 an hour. And how much does she earn per hour working on Saturdays? $6 an hour. So, we also learned that the total number of hours that she worked was 12. And if they're calling this one S, what will weekdays be? 12 minus S. Okay? The product of these 2 items give us our income. So 5 times 12 minus S and 6 times S. By the way, what did they say her total income was? $64.50. All right. That being the case, we're going to combine her weekday income with her Saturday income, all together giving us $64.50. As we go ahead and distribute and combine, we'll get 60 minus 5S plus 6S equals $64.50. Let's combine like terms. And what do I get? S, right? Let's subtract 60 from both sides. And I get S equals $4.50. S equals, 4.5. So what is 4.5? That's how many hours she worked on Saturdays. How many did she work during the week? Well, it's the difference of that and that, which is what, 7.5? Okay? They didn't actually tell us to solve it, but now you can. How many hours did she work on Saturday? Saturday, she worked 4.5 hours based on all that calculating. Good? Ernesto purchased 100 postage stamps worth $9.90. Half of them were 1-cent stamps. How many, the rest of them were 14s and 22s. How many did he buy of the 22 jobbers? Okay, let's hurry up and set this up. We've got 1-cent stamps, 14 stamps. So this is his collection of stamps that we referred to earlier as something you could be collecting. The number of stamps multiplied by the price or the value, okay, will give you the cost. Okay, how much is a 1-cent stamp worth? I'm going to say 1 cent. A 14-cent stamp is worth 14, and a 22 stamp is worth 22. Now the reason I'm doing this is because of their hint. When I get to $9.90, I'm going to call it 990 cents. It's just easier and quicker to work with it that way. All right? I already know some items about this. I know that he had a total of 100. Okay? So this is a total of 100. This plus this plus this. Half of them are 1 centers. How much is half of 100? Good. The rest were 14s and 22s. So if I call this one X, then what's left of this is 50. So it's 50 minus X. Okay? 50, it's 50 times 1. 14, 50 minus X. 22X. all together will give you 990 cents.